So we're recording now?
Yeah, we are now.
Okay, so let's get into it. Last time we were talking about who are the parties involved, what sort of projects are we involved in. Now we're down to what is the process. All work that we do is a process. So that, there's a number of steps involved to get to where we need to in the project. So I've just picked a couple of examples here of the common type of work that we do. Firstly, what we call construct only. We're given a set of documents, mechanical services design documents, specification and drawings that sets out the requirements for the project. Our responsibility on these projects is to check through the documents and look for any contradictions, discrepancies, code compliance issues, etc. And if we do find things that we don't believe are correct, we can request information. So are you familiar with that process? We call it an RFI, request for information. That's an important thing to get out early in the project to get any questions answered so we can move on with the project. Once we've done that and we get the answers we need, we can make a start. And a couple of things that we need to do early on in the project to check the airflows. The specifications will come with equipment schedules and the drawings. So we can check the drawings, add up the airflows shown on the drawings, compare that to the equipment schedules and make sure that that's correct. Now, quite often it turns out that there is a discrepancy in those. So there'll be the equipment schedules will give you a capacity and an airflow, and the drawings may not match. So that needs to be resolved. But once we've resolved all those issues, then we can start to work through checking the duct layouts. There might be some improvements we can make to the duct layouts. And Jill and I were looking at this last week. Maybe we can reduce the length of the duct, use more flexible duct and things like that. In this process, we'll prepare sketches. We might use the design drawings and mark them up, or we might produce a separate sketch ourselves. And once the sketches are done, well, another thing we can do before we actually do that is to check that the equipment capacity specified look correct. And we can do that by the kilowatt capacity of the equipment divided by the area, the floor area that it serves, will give a figure of watts per square metre. Then we can see whether that looks high or low, and you'd have to talk to Ivan or Philip or myself to see initially whether you think that's correct. So, for instance, it works out at 100 watts per square metre for an internal zone. That's probably about the right number. For a perimeter zone, if it turns out to be about, say, 120 or probably a bit higher, 150, then that's probably about the right figure. But if it turns out to be 500 or 1,000, there's something wrong, and that needs to be sorted out. So then we can go, we've sorted out the airflows, we know that they're correct. Then we can go through the sketching of the duct systems. We can check the duct sizes. We can look at changing duct sizes if appropriate, if we feel that we can reduce the duct sizes. Excuse me a second.
Oh, sorry. Oh, come back, you tell me.
You still there? Hello,
Yep,
Yes, we
still
hear.
here, still here.
sorry. Somebody was at the front door and my wife's not home, so I had to go and answer the door.
Right.
Okay, sorry about that. So we've got the airflows. We've been through the ductwork. We've made an attempt to improve the duct layout. Obviously, that's going to save some money for the contractor if we can change the duct layout. Marked up any changes. Now, what we can do then is start to do the fan static calculations. So you're both familiar with these. And once we've done the fan static calculations, then we're in a position where the fans can be selected, or we can send out to fan suppliers to get quotes for equipment. Now, one thing that we'll move on to soon is looking at fan selections. Dua, I suppose you've had some experience with fan selections, but Jelen may not have. Is that correct?
Yeah, that's right.
So we'll get to that. So once we've got the fan statics, we've selected the fans. We can either select them ourselves, and I'll run through that with you in the FanTech selection program. Not today, but later on. Or we've got some quotes for the fans. We can look at the quotes. If we're satisfied with those, we then prepare the equipment schedules. We do fan schedules. The same process occurs for the air conditioning units. Once we've sorted out the units we're going to use, we can put them on a schedule. Now, the schedules serve a number of purposes. They're quite important. We have to normally, one of the processes is to issue the schedules for approval. So we prepare the schedule. Once we're happy with everything that's on there, we put it in for approval. Then it'll go to the builder. If there's a consultant involved, they will check it. If they're happy with it, they'll approve it. In other words, they'll accept that we can use it on the project. And then it comes back to us. We check again. If we're satisfied that everything is correct, we can update the schedule to construction issue, which means it's ready to be ordered. The equipment can be ordered. And also we issue that to drafting. So with the sketches that you've done and the schedules for construction, that can go to the draftsman, drafter, and they can start to produce the workshop drawings. Workshop drawings or shop drawings, you're familiar with, you've seen them already. They're produced in fine detail to enable manufacture of the ductwork and installation on site. So during construction, just following the process through, there may be some changes. Design changes occur on site for whatever reason. The equipment that may be affected by it, the fans and air conditioning units, may have to change, in which case we go through the process again, select the equipment, schedule it, put it in for approval, and obviously update our schedules. So these schedules can change a number of times on a large project in particular. Things keep changing, the schedules keep getting updated, and it's important to keep them up to date so that everyone involved in the project has got the latest information about what equipment is going to be installed. And it affects a lot of people. It affects our people, the drafting, our construction site team, the engineering team need to know what's the latest and so on. Once the construction is finished and everything's been commissioned, then we're ready to produce the operation and maintenance manual. And the finalised equipment schedules will go into the manual, and they will be updated again to as installed. So we've come to the end of that project. Any questions? It's I can't see you too. I don't know if I can change this so I can see you. It's a bit makes it a little bit hard to see whether you've got any feedback or not.
Oh, no.
All good.
Can you
right?
see me?
Yeah, we can see you.
You can see me. I can't see you. What do I have to do to change that?
Click on Teams, see what happens.
Click on Teams. Oh, there we go. So I can see you there.
Can you see your
Uh,
documents? Now we can see your background.
Okay. I'll click there. Okay, there you are. Gotcha.
Is this
That was
een
easy.
peacock verder? Strike to
Okay.
All right. Okay. All
Any
right.
questions so far on that? Was that clear enough?
Yeah, that's really clear.
Okay. Let's continue on. Design and construct. This is probably the more common way that you do your work these days. And in this case, it means that we have responsibility for the design as well. So it can happen in various ways, but probably the most common way is you'll have a set of architectural drawings. You may get a design brief from our client, our client is the subcontractor. His client would be the builder. The builder might provide him with a design brief. So you're doing a hotel. Most hotel chains have their own design brief. So they would give it to us, and we would use that as a basis for our design. So with the architectural drawings and the design brief, we can start the process of collecting the data to do the heat loads. So this is basically step one. And before we can actually start the heat loads, we need to come up with design criteria. Design criteria may be given in the design brief, or it may not. So if it's not, we can get it from ERA. The ERA technical manual will give you the design information, or it comes on Camel anyway, for the location that you're working in. The external design information will be there. The interior design information may be in the design brief, or you can negotiate that with the client. We'll talk about that a bit later when we get down to more detail about heat loads. So the process then is to enter all the data and do the heat loads in Camel. The heat loads can be done manually as well, which you can find the process in ERA DA09. And we'll probably go through that at some stage, because I think that's good background to heat loads, where all this information comes from. So if you're looking for a reference, ERA DA09 is in your files under industry design information. And basically all that information is what's been used in the Camel program to develop that program. That's where it's all come from. So you've used Camel, haven't you?
Yeah.
You haven't used it yet, Jalen, have you?
I've had some brief exposure to it, but yeah,
Okay.
not really.
Okay. All right. So do the heat loads, and we get an output. So if we're satisfied that the output's correct, now once again, there's a few check figures in Camel when you get your output, such as watts per square metre, litres per second per square metre, things like that. If you look at those, you can get a pretty quick idea of whether the answer is right or wrong. So for a typical building, your heat load might turn out to be, let's say, 120 watts a square metre. And if you get that answer, you're probably got the right answer. If you get an answer like 1,000 watts a square metre, there's something wrong. I'll give you an example. Years ago, we were doing a resort project, and I had a young engineer helping me do the heat loads. and she spent a lot of time on it, worked very hard, came back and gave me a computer output and put it in front of me. In those days, we had the big wide computer paper, and she had a whole lot of paper had been printed out, brought it to me, put it on the desk in front of me, and I looked at it and I said, it's wrong. And in a nice way. She said, what do you mean it's wrong? I said, it can't be right. Why? Because the answer was 1,000 watts a square metre. I said, it can't possibly be 1,000 watts a square metre. Oh, okay, why not? Well, it just doesn't work like that. Now, to get check figures, the ERA guide again has check figures for all different types of buildings. So if you want to get an idea of what it should be, and I know Dua's been working on something similar recently, an office building, ERA technical manual has got a whole list of different buildings and what the typical sort of watts per square metre should be. It doesn't mean that's what it is, but it gives you a guide. So for instance, a restaurant might be 300 watts a square metre because you've got cooking, you've got a lot of people in there and so on. A laboratory could be quite low because really there's not much heat load in there. So on and so on, like a computer room, data center or a comms room might be 500 watts a square metre because there's a lot of equipment generating heat in a small space. So it just gives you an idea of what the answer should be. And once you're happy that you've got the right answers, then we start the process of scheduling equipment again. We can schedule, so Camel will give us the equipment capacities and the airflows that we need, okay? So there's two things we can do now. We can schedule all the air conditioning equipment and we can schedule the fans. Well, air conditioning equipment, including fans, and there will be other fans. There'll be outside air fans, there'll be exhaust fans and so on. So you can work through that process. Again, we have the airflows. In this case, we probably don't have a drawing of how the air is distributed. So I need to come up with a layout of all the air outlets and then join those up with ductwork. And so you've been preparing sketches with Bluebeam, I think, at the moment. Is that right?
Yeah.
Philip, I believe his ultimate goal is for you guys to be using Revit. Okay, so that you haven't done any training with Revit yet, I suppose, have you?
No, not yet. I have first meeting later today, so with Esmia. Oh, sorry, Esmia and Dan. Yeah.
Yeah. So I think in the future, that's what Philip would like to see. Philip and I, that you guys do some preliminary design on Revit. And Revit is a pretty powerful tool, really. There'll be a lot more benefits apart from just drawing ductwork. But the idea of using Revit is that when you pass it on to the drafter, some basic groundwork has already been done. So they can actually take what you've done and start to turn that into a workshop drawing. Yeah. Rather than just look at
I'm familiar with Revit. I worked on it for several, let's call them months, not years exactly. I'm more familiar with AutoCAD. But once Revit was introduced in the industry, we had to get a training, start working. But the company I worked with made a transition in the way we deal with Revit, because it's not like AutoCAD. I mean, it requires a lot of technical skills to build a model, especially in the mechanical works. So the intent at that time was to assign drafting to engineers, so they were drafting and designing at the same time. Because if it is just a draftsman who was trained to draft and convert your hand sketches into drawings, he wouldn't have that skill to estimate the right from wrong or what really works, or what coordination skills he needs when it comes to Revit. Revit is 3D. So if the ducting guy is running his ducts while the piping guy is running his pipes, they are working together on a live model at the same time. So they can see what each other is doing. A draftsman to draftsman sometimes do not have the skills to coordinate and design and redesign, reroute, probably change the whole thing because something structural came up the way, or electrical people did something that made us change, or the architects did a big change. So I think Revit needs higher skills, but it's so powerful that you can, if it is built correctly, the amount of information is huge that makes your model ready to be constructed, to be built. You can also convert your items into schedule of equipment, into list of materials that can be immediately sent to suppliers to be purchased.
Yeah, so that's probably something that's going to happen in the future, and there'll be a learning curve involved in that for some period, but it's probably going to be helpful in the long run.
Yeah, it is.
To use the tools that are available to you. So we've got to the stage where we've got a layout now, whether it's Bluebeam or Revit. Now Revit also will probably calculate the static pressure, won't it? So there's another benefit there, that you don't have to go through that process of calculating the fan statics. But as it stands at the moment, with your sketch, you can do a fan static calculation. And so you go through the process again, do the fan statics, and then you can schedule fans and air conditioning units, and go through the same process of issuing for approval, for construction. Then the equipment can be procured. The draftsman can get on with the work that they're doing. And then you go into construction. So this is, I've sort of made this fairly brief. I hope it's been clear that this is just a step one, if you like, of the sort of work you're doing at the moment. You've got mainly air-cooled air conditioning equipment and fans. They're the major pieces of or types of equipment that you're dealing with at the moment. The mechanical services industry is a lot, or has a lot more scope than what you're dealing with right now. Okay, and later on down the track, you're going to get involved in larger projects, which will have chillers, which chill water. I don't know whether you've come across those, Dua. Have you been involved with chillers?
Yeah, absolutely.
Chillers, okay, chillers, cooling towers, boilers, hot water boilers, steam boilers, and a lot of pipe work. Now, at the moment, you guys really aren't doing that sort of work. So I'm just focusing on a starting point for air-cooled equipment and fans. So fan static calculations, heat load calculations, scheduling equipment, and following that process is probably the thing that you do most, more than anything else at the moment. If we've got a couple of minutes left, you got any questions so far on what I've been talking about?
No, I'm good.
Oh, good thing.
Okay, I'll just to finish off, we'll talk about what is the construction program. Okay, this is a very important document. Every project has a timeline. Through design, there's a design program, and then through construction, there's a construction program. We're very much involved with that. and I guess Ivan and Philip, I don't know whether they've spoken about this much, but there's always a time frame. You know, we have to meet deadlines. And so Philip might, or Ivan might say to you, I've got a job that I want you to do. It needs to be finished by next week, next Friday. Okay. Usually that is because your client has said, I have to have this by Friday because then we have to order the equipment, we have to install it, and so on. Okay. So just be aware that time is important, and that if Ivan or Philip give you a job to do, a good question to ask straight away is, when do you need it? They might tell you that. They might say, I need this done by next Monday. If they don't, you should ask, and get into the habit of being very conscious of timeframes. And because what can happen is, as you go along, you might have a number of projects. You probably already do. Or you've probably got a number of projects that you're working on. And so you've got to shuffle. Unfortunately, this is part of the job, that you need to understand what the priorities are, okay? And so that you can organise your work. So if they give you 5 jobs to do, I'm not saying they would, but I know they've got a lot of work on their plate, and you might end up with several jobs to do. You've got to say, okay, well, we need to work out what the priorities are. I'm sure you do that because it's a natural, it's a natural thing to do. But I just wanted to mention this because it is important, and it's a very contractual thing. Possibly not so much for us. We work for the subcontractor, but it is for him, for the subcontractor. I say him, but that company, to comply with the construction program, because there are financial penalties if they don't. Okay.
All right.
So that's half hour. That's probably a good time to stop if you're happy to stop there.
Yes, please.
And
Thank you.
we can continue next time. The next topic is design criteria, and then we go into heat loads in a bit more detail. So we'll talk about that next time.
Sounds good.
Thank you for your time.
Do you want to make it next Tuesday again, same time?
Yeah.
All right.
Sounds
Good.
Yeah.
Thank you. I'll send out the invitation.
Yes.
And Jelen, would you mind saving that, please, again in the usual spot?
Yeah, no worries.
Okay. All
Thanks,
right.
Peter.
Thank you.
See you.
See you soon. Okay.
Bye. Thank you.
Bye-bye. Are you going to stop that, Jelen, or? You still there, Jelen?